This assessment asks us to draw the mechanism for this acid-catalyzed aldol dimerization reaction. The first step of this mechanism will be to protonate water with sulfuric acid. So the oxygen will be protonated by sulfuric acid to form H3O+. Then we can use a lone pair on the aldehyde oxygen, and that oxygen will be protonated by H3O+ to form a protonated aldehyde intermediate. That protonated aldehyde intermediate can be turned into an enol by deprotonation with water. The water can take the alpha proton, form the carbon-carbon double bond, break the carbonyl bond, and form a carbon-oxygen single bond. And this enol will be our nucleophile that will react with another molecule of the protonated aldehyde. We'll have another molecule of the aldehyde that has already been protonated through the same mechanism. Let's go ahead and add some carbon numbers here as well. So we're going to use carbon number 2 to attack carbon number 4. That'll break the carbonyl oxygen, carbon-oxygen bond, kick electrons up onto oxygen. I think I forgot an arrow over here. First, we're going to take a pair of electrons from oxygen to form the carbon-oxygen double bond. That will form a new carbonyl bond between the oxygen and carbon number 1. Carbon number 2 will attack carbon number 4. We still have carbon number 5 and 6. We still have carbon number 3. The 4-oxygen bond breaks, and we get a new single bond between carbon number 4 and oxygen. All that's left here to do to the end is to form the double bond. So we'll do a little bit of proton shuffling. We'll take some water and use some water to remove the proton from the carbonyl. That gives us H3O+. And we'll transfer that proton over to the alcohol oxygen. That turns that oxygen into a good leaving group. And then we can use one more molecule of water to remove this alpha hydrogen from carbon number 2 to form the pi bond between carbon number 2 and 4, kicking out water as a leaving group. That will form our final product. This is the mechanism for this acid-catalyzed aldol dimerization reaction.